let us continue with unit 2 of information retrieval system, which is whole and soul based on how user is getting feedback related to his query. So, unit 2 is whole and soul based on relevance feedback. Now, in unit 2, the third point is clustering algorithm. Already in last video, that was the second video of unit 2, we have seen what do you mean by clustering. Clustering means what? Grouping together the documents. Now there are two types of the clustering. One is a document clustering and another one is a term clustering. So for this document clustering or the term clustering, what are the different type of the algorithm we are using? How we are putting documents together in a group. So for that purpose, you are having two algorithms in your syllabus. One is a k-means clustering algorithm and another one is a hierarchical clustering algorithm. So first let us start with k-means clustering algorithm. Now actually before going deep into the k-means clustering algorithm, I would like to stress on applications of clustering in information retrieval. Means why we want to put together documents in a group, why we want to form the cluster of the document. The first one is it is very easy for navigation and analysis purpose. Means all the documents in that particular group will be analyzed by your retrieval system. So though user is not asking the next document, means without typing the user is getting the output required. Then the next one is what? As user is getting his required information without typing, the recall in search application is improved. Okay, and even it is used for better navigation, as I told you earlier, and as without wasting the time for typing, what we are doing here is the retrieval process is speed up. Okay, so these are all the advantages of clustering in information retrieval system. So as I told you, what are the different algorithms of clustering? The first one is what? Without applying any algorithm, just go on putting together your documents in a group. So that is what called as random or partial partitioning. What it is called? Random or partial partitioning. And now if I want to make a effective clustering, if I want to make a effective partitioning, then I should go for the k-means clustering algorithm, and which is also known as a model based clustering. Now the next clustering algorithm type is what? Hierarchical clustering. Now which is having again two types. One is a bottom up and second one is a top down. Means whatever hierarchical structure, a tree like structure is formed, in that structure you are going to group together bottom up wise or top down wise. When you are coming top down wise, then it is known as a divisive, and when you are going bottom up wise, it is known as a agglomerative clustering. Okay, so these are the two subtypes of your hierarchical clustering. Now another division of clustering algorithm is hard and soft clustering, based on how your documents are repeated, based on the repetition of the document. Now what do you mean by hard clustering? Hard means what? It is a very strict clustering which avoids the repetition of documents in the groups. So each document is belonging to exactly one cluster. So that is what known as a hard clustering, and it is only the most useful clustering because it is saving your memory and it is avoiding the repetition of data. The next one is what? Soft clustering. A document can belong to more than one cluster. Okay, then it is called as a soft clustering. For example, a person, he may act as a faculty in a college, he may be employee in a bank, or he may be a society member. So the same person's information is repeated in these three places. So in that case, you will go for what? Soft clustering. Okay, so in soft clustering, what we are doing is means when there is a repetition of data required, then in that case go for the soft clustering. Now the next one is what? Partitioning algorithms. Now means how your k-means algorithm is proceeding. we are having how many documents? We are having the n number of the documents. How many clusters we want to form? We want to form the k clusters. That's why the name given is what? K means clustering. Now just make a note here that the k is capital, not small. Now what is the use of small k? Are we using in this algorithm? That I will let you know. Okay. Now what we are doing is, what is the input to our k means algorithm? A set of the documents and the number k. Means there will be a set of the documents are available, and these documents you want to divide into clusters, and how many clusters, that is specified by k. Now it is not specified in each k how many documents you are putting, that is not specified. Okay. Now the partition of k cluster is the output. Okay. And this partitioning should be the optimized one based on what is the partitioning criteria you have chosen. Now what I want, on what basis I will say that it is optimized? It should be globally optimized. Okay. It should be means that cluster should be able to satisfy my objective. Okay. And the next one is what? Effective heuristic methods are the k-means clustering and k-medoids algorithm. Okay. But mainly we will see only the k-means clustering algorithm. Now how we are proceeding in k-means clustering algorithm? The k-means clustering is based on a seed. That seed is called as a centroid of the cluster. Another name of the seed is what? Centroid of the cluster. The another name for that centroid is center of gravity or mean. Now here what we are assuming is each document is represented by the vector. Okay. Now based on the new documents similarity with the centroid of existing cluster, the document will be assigned to the corresponding cluster. Are you understanding? What we are having, each document is represented by a vector, and each cluster is having a centroid, that is known as a representative of that cluster or the mean of that cluster, the center point of that cluster. Okay. So based on the distance between the new document with this centroid, the document will be assigned to that cluster. Now here mu means what? The mean of your cluster. Cluster is the C, and what I am doing is I am taking the in how I am finding the mean, the all the documents. So each of document is represented by the x. All those documents I will put together and it will be divided by the absolute value of my C. Okay. And how we are reassigning the new instances to the cluster is based on the distance of the new document from the current cluster centroid. This is very important. Okay. Or you can consider a similarity coefficient, that is the cosine value. Now what are the steps for your k-means clustering algorithm? First, when I have just started with clustering, I don't know that a particular centroid is a perfect centroid. So in the starting stage of my algorithm, in the first step of my algorithm, I will call it as a seed. Okay. Now as I am having a capital K number of clusters, how many seeds I want? I want the seeds from S1 to Sk. First I have to decide a seed randomly for each cluster. Then what is my target? Whatever is that seed I want to turn into centroid. So then only it is an optimal clustering algorithm. And when I want to assign a document to the cluster, it will be assigned based on its distance with the seed, that is the centroid, and that should be minimum. So the clustering process will be repeated till the document is assigned to the correct cluster. So that step is called as converging. What that step is called? Converging. Okay. So and next again the seed is updated as a centroid of each cluster. As I told you, whatever seed I am selecting as a randomly as a center point of the cluster, it is not the final one. It should be updated, and when it is updated, it becomes the centroid of that cluster. Okay. So your seed is what? The mean of the cluster. Sj is what? Mu means what? The mean symbol of the cluster Cj. Now here you can see that the k is equal to 2, means you can see here, you can see here Okay. You can see here there is a one group of documents and this is the another group of documents. So, the K is what? 2. Okay. One second. Now, this is my one group of document and this is my another group of document. Now, initially I will have randomly selected seed here. Okay. Now, I am not saying that this is my final centroid. When a new document arrives, then I will find out the similarity, the cosine parameter, or based on the Euclidean distance, that new document similarity with the centroid. And based on that, I will decide whether this new document should be assigned to this cluster or not. Okay. So, like this we are proceeding. One second. Now, here what we are doing, what are the steps? First, you will pick up seeds randomly. Then, you will assign your documents to the cluster. As I told, these seeds are not the final one. Okay. Now, I want to find out the perfect centroid of my cluster, means seed should be converted to the centroid. So, what will be my step? Compute the centroid. Then again reassign the clusters. Okay. And then this process should be repeated, compute the centroid. So, this repetition of computing the centroid, reassigning to the cluster is called as converging of K-means algorithm, means you have reached to a stop point in which the documents are perfectly divided into groups, the documents are perfectly divided into clusters. Now, till what point you will keep on repeating your steps, means when you think that your algorithm is converged, when you think that you have reached to a stop point, it based on a fixed number of the iterations. The document partitioning is not changing, though I am repeating the steps, and the centroid position is not changing. Then when one of these condition is satisfied, means your algorithm is converged. Now, that is what convergence means. What the K-means algorithm has reached to a fixed point, means the clusters are not at all changing. Whatever documents are belonging to that cluster, they are there only, they are not shifted to another cluster, or a specific number of the iterations has been completed. So, we can say that it has reached to its maximum output, the maximum expectation. Then we can say that it is a converged. Okay. Now, means what will be the convergence condition? When you can say that the K-means has reached to a stop point, then for that purpose I am defining a goodness measure, cluster K. Now, here as I told you, this K is what? Lowercase, and that is the sum of squared distance from the cluster centroid. Okay. Now, I want a document DI to be put into a particular cluster. Then what I will find out? A sum of square of distance between the document and the centroid, and this is what called as the goodness measure. Then I will find out the sum of such all goodness measures, and based on that the assignment I will change. Okay. Now, how we can change that goodness measure? Now, as I told you, the goodness measure is what? A sum of square of the difference between the document and your centroid. Now, instead of this square, if I multiply it by 2 and I want the distance to be minimum, then only the document can be assigned to that cluster. Then when we are saying it as a minimum, means you can say it as a 0, means it is exactly belonging to that cluster. Then summation of that document is equal to summation of A. Then in that case I am multiplying A by a constant M. When this point is reached, then you can say that K-means is converged. Okay. Now, the time complexity is based on your M, that is what the dimensionality of vector, or it is based on your number of clusters and the number of the documents, and it is even based on the number of the documents and dimensionality of each vector. So, all these factors you should consider for your every step. Means there will be, first of all, you are computing the distance between the document, then you are reassigning it to the cluster, you are computing the centroid. So, all these steps will have a specific time complexity which is depending on your number of cluster, dimensionality of your vector, and the number of the documents, etc. Now, you can see that on what basis you are choosing a set. Okay. Now, look at this example. Okay. Now, here B and E I am considering as a set. Now, I want to assign the documents to these sets. Okay. Now, you can see that these 4 documents are very close to each other. So, their distance will be less, but when I am considering about the document C and F, they are far away. So, how your clusters will be formed? A, B, D will be one cluster and C and F will be the another cluster. Okay. Now, there are some variations in it. Means what is the stop point for your k-means clustering algorithm? Means at what point you will converge and how you are deciding whether a particular document is matching to the centroid or not. Okay. So, your main aim is what, how you are deciding the number of the clusters, and I want a right partitioning, I want a appropriate partitioning. Okay. So, this is all about your k-means clustering algorithm. Thank you.